derive and apply a formula for arc length. So we're going to figure out where the formula came from. And we're going to develop some formulas for areas of sectors and segments. And we're going to develop and apply a formula for the perimeter of a sector as well. It says that the degree measure of an arc, which is what we've been dealing with right now. Remember, the degree measure is twice of the angle that's intercepting it, okay? So the degree measure of the arc, we call that theta, because theta is a degree, okay, is theta. Think of theta as an x, but you know specifically that this theta deals with arc measure, okay? And then we also have the circumference of a circle, C, letter C, and then we have the length of the arc, L, length of the arc. Now the length of the arc and the degree measure of the arc is different. The degree measure is in degrees, whereas the length is in units, either feet, inches, units, some sort of unit, okay? So we have this given by the length of the arc divided by the circumference of the circle is equal to the degree measure of the arc divided by 360. So what I just said right there, L over C is equal to theta over 360. We can simplify this because remember, we want the length of the arc. So if we solve for length of arc, we would multiply both sides by C, and we would get L is equal to circumference of the circle times the degree measure of the arc divided by 360, and that will give us the length of the arc. The formula for circumference, remember circumference of a circle is 2 pi r. We're going to let C be 2 pi r in that equation that we just looked at. So we end up with L is equal to 2 pi r, which was previously called C, times theta divided by 360. So again, in words, this is the length of the arc is equal to 2 pi r, circumference, times theta, which is the degree measure of our arc, divided by 360. Okay, we're going to simplify again because 2 and 180 can reduce. So 2 goes into 2 once, 2 goes into 360 180 times. So we get L is equal to pi r theta divided by 180. And that is our formula for the length of arc, which not to be confused with the degree measure. Degree measure we get from the angle, length of arc we get from the formula. The sector of a circle is bounded by 2 radii in the intercepted arc. So we've got 2 radii. So remember, radii are going to go towards the center. So we also have a segment. The segment of the circle is bounded by a chord and its intercepted arc. See a sector, you're going to have 2 radii. Here's one radii, here's another radii. Okay, the segment, you're going to have this chord here. Going to have the chord. All right. Is given by the proportion A over C equals theta over 360. Solving for A, right, because that's what the area of the sector is, we're going to multiply both sides by A of C, getting A is equal to A of C times theta over 360. So again, A is the area of the sector, which is what we want to know. A sub C is the area of the circle. So that little C means circle, right? Area of the circle. And theta, again, is going to be the arc measure in degrees. Not to be confused with arc length, arc measure in degrees. In degrees. So we know that the area of a circle is pi r squared. So we're going to go ahead and substitute pi r squared for that A sub C, so we don't have to look at it anymore. And when we do that, we get A, which is area of a circle, equals pi r squared, area of a circle, times theta, which is the degree measure of the arc, divided by 360. And that is our formula for area of a sector. We have a circle, and we want to find the area of the segment formed by the chord CD. Okay, so CD again is right here, CD, right? And we want the area of the segment. Remember, the segment is just this little piece right in here. That's all we want. That's all we want. Okay, that's all we want. So first, we had to find the area of the sector. So all of this whole piece, that's what we're going to do first, okay? So we're going to use our formula. Area of a sector is A equals pi r squared theta over 360. So our r, our radius, is 8. And our theta, which is the measure of the arc in degrees, is 60. Those are already both given to us. So we can plug 8 and 60 into our formula. So A is equal to pi times 8 squared times 60 divided by 360. If we go ahead and do the math and simplify, we get that the area is 32 pi divided by 3. And that's the area of a sector. And that's the entire, this whole white portion of the circle. That's the area of the sector. Okay? Remember though, we don't want the sector. We just want this little bitty piece, the segment, right? Formed by that chord CD. So step we want to find the area of the equilateral triangle PDC. PDC. Do you notice that this triangle what needs to be taken away from the sector in order for us to find that little segment that one? Because remember, we want this piece. And the first step, step 1, we found the entire sector. And now we're going to find this area of this triangle. And the reason why is because if we subtract the area of the triangle from the entire sector, we can figure out what our little segment is. Okay, so step 2, find the area of the equilateral triangle PDC. You had to know the formula for area of an equilateral triangle, which I hope is on your note card. So the area of equilateral triangle is s squared times the square root of 3 divided by 4. Okay, so S is the side, and our side is 8. So we have 8 squared times the square root of 3 divided by 4, which is 64 times the square root of 3 divided by 4, which in 64 and 4 reduce to 16. So our area of the triangle is 16 square roots of 3. So remember, that was the triangle. In the first step, we solved the entire sector. And we just want this little small part. So what we're going to subtract to find the area of this segment. We want this little piece, this area. Okay. So again, the area of the sector. This is a typo. This says segment right here. It should say sector, right? Right here. The area of the sector minus the area of the triangle will give us the area of the segment. Okay, sorry about the typo. This right here, it says segment, should say sector, right? Area of a sector minus the area of the triangle should give us the area of the segment. Okay, so the area of the sector was 32 pi over 3. The area of the triangle was 16 times the square root of 3. So we can go ahead and approximate that with our calculator. We're going to plug 32 pi divided by 3, figure out what that is, and then we're going to subtract 16 times the square root of 3, and then we get approximately 5.8 square units. Remember, we have to do square units because it is area. Let's say we want the perimeter of the sector intercepting xy. So remember, a sector is formed by 2 radii. So the sector is from here to here and all of this. So we want the perimeter, which is the distance around. The distance around. Okay, so what we're going to do, step 1, we want to find the length we want to find the distance of this arc, x, y. Okay, so we know that we can get the measure of the degree of the arc because it's the double of the angle. So that would be 220. But we don't need a degree. We need like inches or centimeters. We need some sort of unit. So to find the length, we have to use our formula. Length is equal to pi r theta divided by 180. Okay, well, we know that our radius is 12, and we know that our theta we said was 220 because it's double 110, 220. So we can plug those numbers in. So we get pi times 12 times 220 divided by 180. We can go ahead and approximate that with our calculator, and we get approximately 23 units. So that is the two radii links to the arc length. Okay, so remember the radii, this radius here was 12, and all radiuses are the same measure. So that means this radius is 12. So we have 12 and 12, and we calculated the arc length to be approximately 23. So to get our perimeter, we add the sides together. 23 plus 12 plus 12 gives us approximately 47 units. We want to find the area of a sector of 20 degrees in a circle of radius 6. I want you to go ahead and try to do this yourself. So look up the formula for the area of a sector. And remember, a sector is 2 radiuses. So you're actually looking for the area of all of this. So it's not going to be as complicated as when we were trying to find the area of a segment. You're trying to find the area of the sector. So you are trying to find the area of all of this right here. So you should be just using the area of a sector formula. Go ahead and pause the video and see if you can figure it out. All right, let's look at what we do. So we'd have to figure out that the formula for the area of a sector was A equals pi r squared times theta divided by 360. Well, since our radius is 6, we would plug in 6 for r, and they gave us the arc measure already, which was nice. They gave us the arc measure of 20, and so our theta is 20. Okay, and so 6 squared is 36. 36 times 20 is 720. So we get 720 pi over 360. That reduces. 360 goes into 720 twice. 360 goes into 360 once, leaving us 2 pi as our answer. 2 pi as our answer. And that is the area of that sector. Today, thank you for watching. Make sure that you took plenty of notes. Remember, I'm grading you on your notes and how much notes you took. So I will see you when I see you. Thank you.